Mobile food trailers frequently encounter ground fault circuit interrupter, or GFCI, tripping issues. This is a common problem that can arise from several potential causes. One significant area to investigate is the neutral to ground connection. Equipment in a mobile food trailer should be grounded, including the neutral connection. If the neutral connection is loose or not properly connected, it can introduce a voltage difference between the neutral and ground wires. Even a slight voltage discrepancy can be enough to trigger a GFCI to trip, as these devices are highly sensitive to imbalances in current flow. Begin by meticulously inspecting all neutral connections within the trailer's electrical system. Ensure each connection is tight, secure, and properly made. Look for any signs of corrosion, damage, or loose wires, as these can all contribute to a faulty neutral connection. The ground wire should also be properly connected to the trailer frame, ensuring a solid and reliable ground path. A second potential cause of GFCI tripping is a ground fault within the trailer's electrical system. A ground fault occurs when electrical current unintentionally flows through the grounding path instead of the intended circuit. This can happen due to damaged wiring, loose connections, or insulation breakdown. To check for a ground fault, utilize a multimeter to measure the voltage between the neutral and ground wires. Set the multimeter to measure alternating current volts, AC volts. A reading significantly above a few volts, perhaps more than 3 volts, indicates a potential ground fault. If a ground fault is suspected, systematically inspect the trailer's wiring, looking for any signs of damage such as cuts, abrasions, or exposed conductors. Pay close attention to areas where wiring may be subject to movement or vibration, as these are common locations for insulation damage to occur. Also, check for any loose connections within junction boxes or at electrical devices. A loose connection can create a high resistance point, leading to heat buildup and potential insulation failure. If a damaged wire is found, repair or replace it immediately. When working with electrical wiring, always disconnect the power supply to the trailer to prevent electrical shock. Safety is paramount. Begin troubleshooting by examining the branch circuits connected to the 6-circuit panel within the trailer. Since the trailer uses 110-volt lighting and an exhaust fan, each of these components should be tested. Visually inspect the wiring for any signs of damage, wear, or improper connections. Check the condition of the insulation and the wires, looking for cracks, cuts, or areas where the insulation may be worn away. These issues can create pathways for current leakage, leading to ground faults. Ensure that all connections are tight and secure. Loose connections can cause increased resistance, which can lead to overheating and potential ground faults. Use a screwdriver to tighten any loose screws on receptacles, switches, and light fixtures. If the problem persists after checking the wiring and connections, move on to testing the individual components. Use a multimeter to check the resistance between the hot, neutral, and ground wires for each circuit. A low resistance reading between the hot or neutral wire and the ground wire indicates a potential ground fault. Isolate each circuit by disconnecting it from the main panel. Then test each component individually. For example, disconnect the lighting fixtures and test them separately. Disconnect the exhaust fan and test it separately. If you find a faulty component, replace it immediately. Another potential factor to consider is the cumulative leakage current for multiple devices. Even if each individual device has a small amount of leakage current, the combined effect can be enough to trip a GFCI. To minimize cumulative leakage current, ensure that all electrical devices used in the trailer are of high quality and meet relevant safety standards. Avoid using cheap or poorly made devices, as these are more likely to have higher leakage current. One more remote possibility is a defective GFCI receptacle. While less likely, GFCIs can fail over time. If you have exhausted all other troubleshooting steps and the GFCI continues to trip, consider replacing it with a new one. When replacing a GFCI, make sure to use a device that is rated for the appropriate voltage and current. Also, follow the manufacturer's instructions for proper installation. Before undertaking any electrical work, it is crucial to prioritize safety. Always disconnect the power supply to the trailer before working on any electrical components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult a qualified electrician. Working with electricity can be dangerous, and it is important to take precautions to prevent electrical shock. Additionally, consider using an isolation transformer. Isolation transformers provide a high degree of isolation between the incoming power supply and the trailer's electrical system. This can help to reduce the risk of ground faults and GFCI tripping. An isolation transformer works by creating a new neutral and ground reference point within the trailer, effectively isolating it from the grounding system of the external power source. This can be particularly helpful in situations where the grounding system of the external power source is unreliable or has a high level of noise. When selecting an isolation transformer, make sure to choose a unit that is rated for the appropriate voltage, current, and frequency. The transformer should also be properly grounded to ensure safe operation. Furthermore, check the polarity of the receptacle. Incorrect wiring of the receptacle providing power to the trailer could cause GFCI tripping. A simple receptacle tester can verify correct wiring, ensuring the hot, neutral, and ground wires are properly connected. Swap the hot and neutral wires could cause the GFCI to trip. The age and condition of the extension cords supplying power to the trailer should also be examined. Old or damaged cords can develop internal shorts or ground faults, leading to GFCI tripping. Visually inspect the cord for any signs of damage, such as cuts, abrasions, or exposed conductors. If any damage is found, replace the cord immediately. Additionally, make sure the cord is rated for outdoor use and is of sufficient gauge to handle the electrical load of the trailer. Undersized cords can overheat and cause voltage drop, which can also contribute to GFCI tripping. It is also good practice to ensure the GFCI receptacles themselves are properly installed. This includes verifying that they are securely mounted and that the wiring connections are tight. Loose or improperly installed receptacles can be prone to vibration and movement, which can lead to loose connections and potential ground faults. Additionally, make sure the receptacles are protected from moisture and physical damage. Outdoor receptacles should be weather resistant and should be covered when not in use. Internal electrical components can corrode over time due to high humidity, temperature fluctuations, and other environmental conditions. Be sure to inspect the inside of the control panel for signs of corrosion. If corrosion is present, it needs to be dealt with. Also, if the GFCIs keep tripping with no load attached to them, then this can be a sign that they are faulty and need replacing. Lastly, the number of appliances connected to the circuit could also cause a GFCI to trip. Each of these appliances consumes power, and if the combined load exceeds the capacity of the circuit, it can cause an overload. Overloads can lead to overheating and potential ground faults, which can trip the GFCI. Be sure to determine the total load in the circuit and compare it to the circuit's capacity. If the load exceeds the capacity, reduce the number of appliances connected to the circuit. Also, consider using power strips with built-in circuit breakers to protect against overloads.